Hey ho! I have a little update of today's work, but first just to show our webpage, datdot.org, where you can read a little bit more about the project if you're interested. We have like a documentation page where you can read about the technology that we use, which is Hypercore Protocol and Substrate Framework. So yeah, if anyone is interested, this is the go-to page to read about it. Package is not downloadable, although it kind of shows that it is. It's just like work in progress, so we're playing a little bit with how it will look. But yeah, the data is here. So what I did during the weekend is, together with Serapat, we were refactoring the main function for a hosting setup for a tester role. The attester is connecting to encoder and hoster, getting the data from encoder, comparing it to other two encoders, and forwarding it then to the hoster if everything is okay. So every attester connects to 3 encoders and 3 hosters. So here is the code to connect the attester to 1 encoder and 1 hoster. And then the attester starts listening to the chunks coming from encoder. And here we handle these chunks. We have a handler, so we check what is the type. If the type is data, we compare the chunks. So this goes into a callback here, where we are waiting for 3 chunks from the same index from 3 different encoders. And when we have it, we compare them with each other, and then we return the promise. And then the attester can continue and send the chunk to the hoster. So because Hypercore is sparsely replicated technology, which means that because it's append-only log, every data is a set of logs. So encoder can get the data from the original author, chunk by chunk, compresses it, and then chunk by chunk send it to the attester, which then compares chunk by chunk and sends it forward to the hoster. So all this is happening in parallel instead of like waiting for encoder to first download everything, compresses it, then forwards everything to the attester, then a tester does comparison, and then forwards to the hoster. So everything is kind of faster and happens in parallel. So yeah, this was basically the refactoring part. So now this hosting setup is done, and it kind of looks a little bit more readable, and it also resembles the state machines that we're going to use in the next stage. So this is the whole logic. It ends here, and then the storage challenges start, or all the challenges actually. So let's just try out the code. So what we do in this simulation, we just create like 10 or 15 accounts, which each run in a separate process. And then we create one contract, which consists of 2 amendments, 2 parts. And each of these parts have a set of attester, 3 encoders, and 3 hosters. So we basically have an attester 209 3 times, and a tester with ID 34 3 times. And then, for example, a tester reports for the amendment 282 and says, yay, hoster number 6, hoster number 77, and hoster 34 start. And then the other attester responds for the amendment 283 that this attester was attesting, and says, yay, my hosters 151, 40, and 28 also started hosting. And then once this is emitted to the chain, we also start the challenges phase, and we basically will now check if these hosters are actually storing and serving the data. So we have 2 types of challenges: storage challenges and performance challenges. So I'll be working on this now, but this code is now more readable and I'm happy about it. So, oops, now I deleted something. I have to put it back. Yay. Okay, see you.